welcome Wes Mason back to the stage in Cardiff. Have you been at PyCon UK here in Cardiff before?
Yes, I did.
Okay. But Wes was also a speaker at the very first Python Django conference in Cardiff back in 2014. So it's good to see you back. Wes works at NPM and works in DevOps, developer operations, and he'll be talking to you about how to keep everyone happy through your work. Thank you, Wes. Please welcome Wes.
Hello. Right, yes, let's move on to that. As Daniel said, I am Wes. You can find me most places as First Vamp. I work at NPM. I've worked at a few other places like Canonical, to name a few. I love open source. And my career has mostly gone down the track of focusing on SRE, DevOps, sysadmin, and automation over the last few years. So why do we care about operations? That's a very easy one to talk about. Operations is the concept of actually putting your product in front of people. Unless someone can actually use that product in production, then there is absolutely no point in building it in the first place. Even if you're an open source maintainer of a package, that's going to be used by someone eventually. Operationalizing just a package is using it and testing it, and maybe even using it in your own product. Most of us probably don't just spend all our days working on open source products. We probably actually build something that users hopefully use. And if you can't put that out onto production and allow people to use that, then what's the point? As a developer, as a sysadmin, SRE, QA engineer, you need to care about operations because that's the end goal. Making something operational is allowing someone to use it, and when things eventually go wrong, because everything goes wrong, I mean, hands up people who've written bug-free code. Put your hand down at the back. Things will eventually go wrong. And it's not just bugs. It's, you deployed something and you picked the wrong database. You didn't scale up enough servers. It turns out that your product uses twice the amount of RAM when more than one person uses it. These inevitable problems get in the way, and you need to make sure that people are not going to quit their jobs because you've made it so terrible when things have been deployed. So this is a typical search result when you look for DevOps tooling. You get lots and lots of results about configuration management systems or the latest deployment tool. And now all of these tools are going to make your life so much easier and solve all the problems. We'll just sprinkle a little DevOps on the top. In case you've not heard the term before, it's fairly popular these days, DevOps is developer and operations. It's the idea that you can't just build silos around, I'm a developer, I built it, and I throw it over the walled garden, and someone's going to deploy it. Everyone needs to share information and also take ownership of the thing that you're building. This is another way in which people quit their jobs because sysadmins especially will get given buggy code and be expected to maintain that in production, be woken up at 2 a.m. and fix a bunch of broken stuff. The thing is it's all broken anyway. I've just discussed that everything is buggy at some point. That's just a natural thing about software development. People aren't perfect. Even machines aren't perfect. So we need to cope for that and cope for the fact that someone is going to have to maintain this when it goes live. And developer operations, DevOps, is all about sharing that information between different teams and people with different specialities so that everyone takes ownership of it in production. So we're talking about infrastructure. This is actually the output of a tool called Juju, or the Juju GUI, which is one of those special, let's deploy everything into the cloud and it all just work tools. But it also makes a nice example of a bunch of servers that have been deployed that do certain things, such as you can see MySQL in the middle there and a few routers on the edges. That doesn't necessarily make a great deal of sense to people. This, if you look at this and you tell me, so where does the code live? Where is my data? Someone's just given me a ticket and the user login is broken. How do I debug that? Where do logs live? Maybe it's a caching problem. Where is the cache? Making sure that everyone understands how infrastructure works from a top-level point of view is just as important as allowing people to use the same tools to deploy that infrastructure in the first place. Because if you can't understand it, if you get cognitive dissonance, just looking at a list of servers, anyone who's gone on to AWS or Azure or Google Cloud Engine and looked at a list of servers and thought, I don't know what these do. They've just got random names, IP addresses. One might be a database server, one might have some code running on it. I don't know. That is what you're contending with, especially when you're contending with being woken up at 2 a.m. in the morning, having a fuzzy brain, PagerDuty's going off at you saying, the database is on fire. I have no idea which one the database is. I don't know what things use that database. So organizing things in a certain way and then documenting around that organization is important, the same as with code. Anyone who's been to a conference before has probably sat through someone telling them how to document their code, how to test their code, how the structure of their project should be laid out. Those of you who this is your first conference or just have been lucky enough not to sit through the same things over and over again about documenting your code, this is a big thing because someone coming across a piece of code for the first time and trying to figure out what it does and how it does that reduces the friction of fixing things or adding new features or general overall maintenance. And it is exactly the same thing with infrastructure. And becomes even more important when you start deploying your infrastructure with code. But just forget about buzzwords for the time being, because they're unimportant. The same as that list of DevOps tooling and all those things that you sprinkle the DevOps and we'll just fix things magically. It's not about the how I'm going to deploy into the cloud using this tool or how everything needs to be microservices and we need to push as much things to the edge and all of these other things. It's all about what your fellow human being can understand from a cold start. If they don't work with these things normally, if they are a sysadmin who doesn't work on the code base, if they are an SRE who only works on certain amounts of code base and looks at infrastructure as code all day long, or they're a developer who hasn't even logged on to a production box before, they need to understand something from the beginning without special language and in terms that they would have been able to understand from the first day of onboarding. Because Wolverine doesn't like being woken up at 2 a.m. in the morning with no documentation. So, back to school for a moment. Documentation. At the risk of sounding a little bit Steve Ballmer-ish and going documentation, 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 it is so important. And no one likes writing documentation. Sorry if there are any technical writers in the room. You are the special unicorns in this case. I once had a particular project which I wrote the best documentation of my career on. It was a 3-day project. Can anyone guess how long I spent writing documentation? 5 days is closer. Yeah. It was the 3 days. The whole 3 days. It was about an hour's worth of code. That was with tests. It was a big deal because it fixed a bunch of things that were breaking on about 100 servers that were deployed. But how it worked was very important, especially if you were on call. being able to turn it off or tweak a certain value. And so I spent three full days writing nice looking, easy to read documentation. I shouldn't use the term easy to read. There was very little cognitive dissonance involved if you were reading it for the first time. There was a low barrier to entry. But it was, 99.9% of that project time was making that documentation, and it was hard. It was so hard going. I didn't want to start in the morning. I must have spent an hour reading Twitter. But it worked, and people were really happy, and everyone seemed to assume that I'd spent 3 days working on this feature. Because that's how important and easy to use it became. There I go with that term, easy. So yeah, code comments everywhere. Even if you don't use infrastructure as code, really you should look at using infrastructure as code. It's great. Even if you don't use the methodology of writing your infrastructure down as code, even something as simple as bash scripts, even if everything is a manual process, imagine if it was code that you were deploying. Imagine that you have written a massive class and you need to document how each of those methods works. That's all deploying infrastructure is. It's calling a bunch of methods. In the same way in which you would document with comments and test cases, methods in your code is exactly how you might deploy a piece of infrastructure or tweak its settings or redeploy it if it's broken. It's methods, comments, test cases. And if you can write a list of methods and comments for those methods and test cases, then you've got pretty good documentation for deploying something. As an extra bonus on the end, I have interactive scripts, because writing everything down as a script that you do over and over again, that's pretty much the basis of infrastructure as code. If you're doing something over and over again, then that's something a computer can do just as well. Don't forget no input as well, because when you start automating things, not asking yes, no in command prompts, yes. So, some examples. This is from, can people read that? I realize it's a little bit small on this screen. I should have tested this beforehand. This is a little bit, these slides, by the way, will be online on GitHub, so you can have a look at the examples at the end. I'll try to muddle through as best as possible for now. This is from a piece of Terraform configuration. Terraform is a tool for deploying things onto multiple clouds. It's great at spinning up servers, databases, routers, all sorts of things. Thank you, Daniel. And the very simple example I have here is that even though it's a relatively small amount of code, and all it does is deploy a database onto Amazon RDS, which is I'm not shilling for Amazon here, but a automated way of deploying a database, a managed database, so you don't have to care about various operations such as backup and version upgrades. It's fairly easy to deploy with Terraform, but there is a lot of knowledge around this. If you don't know much about Postgres or Amazon, about AWS or RDS or even Terraform, this is the first time you've used Terraform, you're on call at 2 a.m. in the morning, you've just broken the watch with your adamantium claws, and you need to redeploy a service. Maybe you've not even used the tool before. You watched the screencast by someone like me telling you how you might do this when you go on call, but you weren't really paying much of attention, you were fiddling with your phone. So you need to be able to look at this code and go, this does this, this does this, and this does this. Comments are great for that. This is why infrastructure as code works so well. And in here, I've included links to the RDS documentation as well on Amazon. Not just the local documentation, this code and what we're doing with it, but also to the actual thing that will be deployed eventually. A second example. So this is a set of scripts that we have at NPM that I wrote to effectively use things like Terraform and all of our other tool set, just like virtualenv. So various people use Macs, they use Linux, there's even one person who uses Windows. And you can source a file and everything will work just like in a virtual env. You don't care how it was installed, it just got installed cross-platform. And everyone in the team has this limited set of commands. They source this, and they can run Terraform apply. They can run an Ansible playbook to deploy a bunch of servers and provision them. And these are at the top of the documentation, and they're only a few steps, and you know exactly what they're going to do, along with examples of what they will do. Just by doing that, by reducing things down into a set of commands that everyone knows that these should do these things. There are edge cases, because there are always edge cases, because all code is bugging. But it's reduced a lot of the cognitive dissonance from a cold start, trying to work with this infrastructure. Some hot takes: identify patterns, record as code. Bunch of unicorns there that do exactly this. NPM does this. Canonical did this. Lots of other places that have done this. It works. As soon as you identify patterns in your infrastructure, just like with code, just like when you refactor code, if you have an app server and a database server and some routers, then you've got a pattern. That's how you deploy something. And you can do that over and over again. And if you teach people that this is how we do that way, they will come to understand it a lot simpler. Then discuss it, document it, and communicate it with everyone. Back to documentation again, back to communication, telling people how it works. But try not to be too dry. Dry is do not repeat yourself, if anyone hasn't seen that term before. As an example, it doesn't come out very well because the comments are in grey on white. However, this is a list of services that are broken down into subdirectories in Terraform. You can very easily have one large resource in Terraform. You can have a bunch of Postgres servers that are all shared by the same applications. You can have cache servers and everything else. But instead, we choose to break them down. Whether it's a microservice or not, this isn't about microservices. This is just about sometimes avoiding the do not repeat yourself adage. Sometimes it helps to repeat yourself because it's a lot easier if someone is looking at an application and it's attached to services and servers and say, this talks to this, does this. If you've got a lot of shared infrastructure, it's great, but you can still break that down either in the documentation or just in your tools and how you list those services and say that these things relate to each other, and that's how I go about debugging that particular work. Code is about maintenance. And if you can achieve maintainability of your documentation of that infrastructure, even if your documentation is the code that deploys the infrastructure and its comments, then you reduce the cognitive dissonance when someone's on call and has to look at maintaining it. I've been Wes. That's where the slides live. I would invite you to look at Human Ops, which is a particularly nice group. They have meetings all over the place. It's related to the HugOps hashtag on Twitter as well. And it's generally about improving empathy in operations for developers, sysadmins, QAs alike. Design Ops is another thing which has recently become more popular, which is around designing UX for operations to reduce cognitive dissonance. Incident Management for IT Operations is a wonderful book that I always recommend to people, no matter what role they do, which was created by effectively a bunch of firefighters and other emergency service people around the concepts of what you do when there is an incident and how you respond to it, but applied to IT operations. I'm around today and tomorrow. The few little pictures there at the beginning and end were by my good friend Jonathan Oliver, who is a great illustrator. If you ever need any illustration work, grab me and say hi. I think we're out of time for questions, so please just grab me in the hallway. Apparently we can take questions if anyone has any. If not, fine. Grab me. Thank you.